Hello everyone, my name is Julius Kaziwe, and I'm going to be presenting one of the problems I've identified in our community and actually I've faced while working somewhere. So uh, one of the problems I've been facing, having a document and you want maybe you have to copy everything manually so that you transform it into a digital form. Like you have your document and it's handwritten, everything is not clear. So I thought of an AI that maybe recognizes handwriting and converts handwritten character into machine readable text. So yeah, this is a problem we are going to be dealing with today. So the problem is, as I've mentioned, handwritten text recognition, and why it matters to us is we need to deal with the manual data entry of handwritten documents, and we start automating that task of you scan a document and you transform whatever characters are in there, segment them the way they are, and then put them right, whichever handwriting the document is written, because many people write in different formats, and some words are not clear, some letters are not, some characters are not clear. You can't tell which letter is this. Some letters are joined. So with this AI, we can be able to scan and interpret all these unclear handwritten inputs from sources like paper documents, and we transfer them into clear digital format like clear text. So the way we are going to apply AI in this handwritten text recognition is we have to first import some libraries and load some data sets. And basically for this project, I'll be using IAM dataset. It has a lot of thousands of predetermined images of different handwritings of different people and in different ways. So we shall be using this to train our module to these different handwritings so that it can easily detect which letter is it, which pattern is it being followed, and so for all of this to work properly, we need to first train our module with this data. So this data is all going to be gotten from the IAM data set that we have to import. And of course, before our AI does any processing, we have to feed data there so that it knows exactly what it's going to do with which characters is it going to, how are these different characters going to look like in different handwritings. So the images that we shall be using as input will not be directly actually fed into the module. So before everything is every character is recognized, there are some operations which are being processed on the data to make it ready for the neural network to recognize these characters. There are some processes and operations which are done, and basically the SNN module is one that does that. So in this module, what it does, it reshapes our image that we're going to input into the AI, reshapes it into a proper dimension that the module needs. So basically, the SSN module consists of the convolutional and polling layers. It works better for data that are presented in good structures. That's why we are going to use the images as our input, because this module is based for that, image classification problems like the one we have, the handwritten recognition, and basically handwritten text recognition, and basically we're going to be using images as our input. Yeah. So as I mentioned earlier, we have to train our module, and training our module, we need the training data, validation data, and since it takes some time it takes some time to train our module. So we need testing data, as I said earlier. We shall be using the IAM dataset. So in this, we have our testing data, we have a comparison data we have to compare with, so that when we have some, when we input some image in our system, it will be able to detect, to compare with this already predefined data, and just wait and see if really this matches to whatever is in the document. So after training the module, we have to evaluate. Evaluation is what actually you're trying to figure out if you're accurate, if the module is accurate in its interpretation. So we have to apply that. Okay. So the type of data intended to be used, as I've mentioned earlier, we're going to be using images, but with these images shall be images that will be of written text, maybe paper documents, or you have a photograph that has written documents. So that's our input, the data that we shall be using. Yeah. And we shall be using mainly supervised learning in our project. So the difference between supervised learning and unsupervised learning is basically we are going to use labeled data to help predict outcomes and adjusting for the correct answer. So we are going to be having already predefined data in our module, and then we are going to be mapping it to a given data. Maybe say we have a character A. We have to tell our module that character A looks like this, character A is this. So we have to map it. We have to predefine it in the module so that the module knows that A looks like this, C looks like this, Z looks like this. So that doesn't have to find out on its own. So yet for the unsupervised learning, the module works out on its own to discover that, the structures of the unlabeled data. Maybe you feed in an image and just figure out which common characters are in here. Maybe I'm having characters that look like, an inverted V with stroke in between, that's an A. So it has to be having that potential to read and understand on its own. Yet for supervised, you have to map. This represents this. Already the system has to be knowing the data before. So the other differences in here are supervised is more accurate because you already know what to determine. Yet for unsupervised, the accuracy is moderate because the system doesn't really know. It guesses on its own. It's like a guess, try and error. It may classify some characters where they don't belong. You may find, maybe say you have an N and R joined together in an handwriting. So this module may interpret it as M at some point. So yeah, those are errors that might happen if we are using unsupervised learning. We might group it into the M, yet it's not an M. Yet for supervised, you already know that an M looks like this, and that's it. As I mentioned earlier, we're going to be using offline, and that's possible when you're using supervised learning. Yet for unsupervised, it has to be real-time analysis of data. And for supervised, a simple method of machine learning, typically calculated through the use of programs like Python that you're going to be using. So you can use Python to, do some calculations upon training and labeling of inputs to a given output variable. Yet it's a little difficult for unsupervised learning. It's a little ambiguous and complex because we need a lot of data to train this module, produce intended outcomes. Yet for supervised, you only need to map this to this, map this to this, and we shall be using languages like Python to do that. So for supervised learning, I'll be using neural networks, as I've mentioned so far, as I mentioned before. It processes training of data by automating tasks through layers of nodes. Yes, each node is made up of inputs and weights and biases, and actually outputs. Yeah, as I said, supervised learning deals with mapping a given input to a given output. So the neural networks do that. Yeah, they have functions that do the mapping. And we shall be using the K nearest neighbor, the KNN algorithm. And this algorithm assumes that similar data points can be found near each other. As a result, it seeks to calculate the distance between data points, usually through the assigning categories based on the most frequent category or average. Yes, so AI technical challenges like to be faced in this, maybe, as I've said, people have different handwritings, and it will be very hard for the AI it will be very tricky for programmers, actually. Like, I'll find it so hard to provide enough examples of how every character will look in every perspective. Like, I can't get all the handwritings of all the people in the world, of course, but I'll try to provide enough data sets to my module so that it knows at least some good percentage of how every character is written. And the other problem is joined characters. You might find someone who writes joined characters, like joins characters, and it will be very hard for the module to figure out which one is which, and we've had to figure out the patterns and figure out each individual character. And actually, even the other technical problem would have been the way photos are portrayed or presented. You might find that a photo was taken when the camera was maybe tilted, and it was very hard for the character to be recognized because it will be in a weird posture. Those are the technical problems I think would be like faced, and probably we can solve this with deep learning and neural networks that we're going to be applying into our project. So deep learning allows machines to learn over time and adapt their output using weight. So more weight can sit on the factors that stay largely the same across handwriting. This means that deep learning is more adaptive to handwriting changes. So even if you're having a lot of people writing in very many different ways, and they are tracing these characters in different ways, the system will have to adapt the changes. So, and here we have some metrics that are going to be using: accuracy, recall, fusion, and F1 score. So HS is a base matrix used for model evaluation, describing the number of correct predictions over all predictions. So you're having all the predictions that the model will make when you maybe feed in an image. And here we are looking at only the correct predictions. Which of them are correct? And then for precision, precision is a measure of how many of the positive predictions made are correct. It's a little confusing, but with positive predictions, here we mean we're only looking at the predictions it has made. We don't look at the whole set of what we fed in and what we have predicted. Here we only look at the predictions it has made. Which of them are correct? Which of them are true positives? And then for recall, it's a measure of how many of the positive cases the classifier correctly predicted over all the positive cases in the data. So it's more likely like precision, but here we look at how many of the positive cases that you already defined that these are the positive ones. We should maybe A looks like this. How many of those? Maybe some were classified as maybe A, maybe was classified as V, module classified it as V. How many of the predictions were correct? So here when you look at the positive cases, if A was meant to be like this, how many A's were predicted correctly out of the total number of A's that we have? Yeah. And then for F1 score, it's a measure combining both precision and recall, and it's being calculated in such a manner. It's like an average of these two. Yeah. And it's called it's described as a harmonic mean of the precision and recall. So here, basically, since we need a percentage of words actually classified by the AI, I think in my project, I'll be using the accuracy and precision evaluation metrics. And here are some of the references to my work. You can check them out if you wish to. And I'm going to basically using these references to come up with this handwritten recognition AI. Thank you for listening, and have a nice time.